Okay, in this video, I want to talk about impediments to creating a properly functioning logical system. Okay, I'm going to break this into two parts. In this first part, I'm going to cover the very basic stuff, and then I'm going to do the more complicated stuff in the next part. So what do I mean by impediments? So basically, impediments to a properly functioning logical system are inconsistency, low coverage, and low precision. For a system to work correctly, you have to the statements in the system need to be consistent. You need to have all of the statements there, and the statements need to be correct. It's pretty straightforward. So let me explain in detail what this means. So if you look at this graphic, the gray area on the outside is some universe of discourse. Say this is financial reporting. And the green circle, which you can barely see, is the aspects of reality within the domain of financial reporting that we're concerned with. The pink circle is the precision and coverage of the tool that you have to create, say, an XBRL taxonomy or instance document for that matter, plus the expressive power of the language, and all those working together. If that works correctly, then you will have a system that can be properly functioning. So the best way to understand what makes a system properly functioning is to show you things that make it not properly functioning, and then you can see what you have to deal with in order to make it properly functioning. So that's what I'm going to do. So I provided this graphic in another video, and what I'm going to do is I'm going to go through each one of these states of a very simple system and explain why it works, and secondly, what causes it to break. Okay, so here is the first state, state one. The logical system, it's the accounting equation. Accountants understand this. Assets, liabilities, equity. And the rule, assets equals liabilities plus equity. And here we have three facts. The facts are consistent. The system is complete. Every rule is specified. There's only one rule. And the information is precise, because assets equals 5,000, liabilities plus equity also equals 5,000. So the system is correct. And below you can see a URL where I have literally created a test in this, and I've represented this in XBRL. I've represented this in Prolog, and someone else is representing this in OWL, and we can show with three different languages that this is a properly functioning logical system. So what if you take that rule out? The rule, assets equals liabilities and equity. What if you didn't have that rule? Someone could still create a financial report and they provided assets, liabilities, and equity. But how would you know if what they're providing is correct or incorrect? What if they provided 3,000 for assets and the same values for liabilities and equity? If you don't have the rule, you don't know whether it's correct. So you have to be able to provide the necessary rules. To do that, you have to have a tool that is capable of doing that. So what this state 2 is showing, that if you do not have a tool that can provide this rule, or if you do not provide the rule in the system, then the system is incomplete, because it's possible for you to create a report and provide values, and the system will not detect that you provided the wrong values, and therefore you can have errors entering the system. And that system is incomplete because you did not provide the rule. So the second, state number 3, imagine that if you did provide the rule and you provided a system that has 3 fact values, assets of 8,000, liabilities of 1,000, and equity of 4,000. Well, liabilities plus equity does not equal assets. So this system is inconsistent per the rule that has been specified. So it's not properly functioning. So basically, if you have the rule and that you're allowed to, you could then test to make sure the values are correct, then you know that the system is working correctly. State number 6 is you have a system that is imprecise. So a logical system is a true and fair representation of reality. Precision is a measure of how precisely your logical system is representing reality. In this case, assets equals liabilities is not reality. In reality, assets equals liabilities plus equity. But here, the system is saying that assets equals liabilities, and the facts state that assets do in fact equal liabilities. However, that is imprecise because that is not reality. So that's a flaw that you can have within your system if you make a logical error in your system. So here I'm showing that a system is incomplete. So, and this is, I don't know how to think about this, but here's what's going on. So here, in some financial reports, people don't report certain high-level line items like, say, liabilities. If they report the concept assets and they report the concept equity, and you know that the formula, you have the assertion assets equals liabilities plus equity, you can derive the value for liabilities. All you do is you use basic math and you turn the equation around, and you find out that liabilities is equal to assets minus equity. So in that way, you can derive the value of liabilities. Now it's safer if all 3 values are provided, but if it's unreported, if liabilities is unreported, this is unsafe, but this can work. So I'm not sure how to think about this. That's why the question mark. So, but this is an incomplete system. If you don't provide the rules, assets equals liabilities and equity, and you provide the fact for equity and you provide the fact for assets, there's no way to derive the value for liabilities because you don't have enough information. So the real world is that assets equals liabilities and equity. If you only provide assets and equity, you can't really assume that liabilities is of a specific value because the system does not have the rule, enough information to derive the value, so it's incomplete. So this diagram explains what I just went over using set theory. And I'm not going to go into this. I'm going to stop where I am for now. And I'm going to talk about these are pretty basic. These are pretty straightforward. Anybody that wants to understand this is pretty straightforward. The other ones are more complicated, which I'll get into those in the next video.